Have you ever stopped and wondered what's really going on inside an ATM? You know, you stick your card in, you punch in a few numbers, and boom, cash comes out. It feels like magic, right? But how does that machine actually know it's you, and more importantly, that you have the money? Well, today, we're going to pull back the curtain and look at the simple yet really powerful logic that makes it all work.
Because at the end of the day, it all comes down to this one question. It's not some crazy, complex AI making a judgment call. Nope. It's just a simple series of yes or no questions. Let's follow that path of logic together, step by step.
All right, so let's set up our challenge. It's a classic, a simple ATM withdrawal. Before a single dollar bill comes out of that slot, the machine has to pass two absolutely critical checks.
And these are the two big ones. Think of them as two security gates. First, security. Does this person even have permission to access this account? And second, logistics. Is the money they're asking for actually there? The machine has to answer both of these questions, and it has to do it in that exact order.
Now, to build this logic, you might think we need a ton of complicated tools, but we don't. We only need three really simple things from our programming toolkit. Let's meet our building blocks.
First up, the variable. This is pretty much the foundation of all of this. Just think of it as a labeled box or a container where the computer can store one piece of information it needs to remember, like your account balance or your PIN.
You know, the source material gives us a perfect analogy for this: labeled jars. It's a great way to picture it. You could have one jar labeled account balance and another one labeled correct PIN. The label tells you what kind of stuff is inside, and the contents, well, they can change. Simple, but it works.
Next up, we've got the if-else statement. This is the real decision maker. It's how we tell the computer, if this one thing is true, then I want you to do this. Else, if it's not true, I want you to do this other thing instead. It's literally the fork in the road for our program.
So what powers that if statement? This little thing called a Boolean. And it is the simplest concept of all. A Boolean value can only be one of two things: true or false. That's it. There's no maybe, no kinda. Is the PIN correct? It's either true or false. Is the balance high enough? True or false? This simple binary choice is the engine behind all computer logic.
Okay, we've got our tools. Let's pop the hood on this thing and actually look inside the ATM's brain. We're going to build this logic piece by piece. So, first things first, the bank's data. We need to set up our variables. So we have one jar called account_balance that's holding the number 500. And we have another jar called correct_PIN holding 1234. This is the official information that's stored on the bank's server. All right, now you walk up to the machine. We need a place to store what you type in. So we create two more variables for your input: entered PIN, which in this case is 1234, and withdrawal amount, which is 200. Okay, the stage is set. The computer has everything it needs. And here it is, our first if statement. The computer asks a very simple question. Is the value inside the entered PIN jar exactly equal to the value inside the correct PIN jar? If it is, great, we move on. But if it's not, the logic immediately jumps down to that else part and spits out an error. That first gate is now secure. Now pay close attention to what's happening inside our first if statement. We put a second one right there. This is a huge concept called nesting, and it's so important. This second check, the one about the balance, it only ever happens if the PIN was correct in the first place. Here, the machine asks, is the withdrawal amount less than or equal to the account balance? And since 200 is less than 500, that condition is true. So the logic inside this if block gets to run. The code updates the account balance and then prints out that success message. And just like that, we've walked the complete, successful path from start to finish. Now, this might seem simple, and it is, but what we just built is a major milestone. This fundamental logic, it's not just for ATMs. It is at the absolute core of almost every piece of software you use. This source material really just nails it with this quote. This concept of nesting is how you build complex decision trees. It's how a program can handle multiple conditions to figure out what to do in a complicated world. By getting this, you're basically understanding the fundamental architecture of how programs think.
So let's recap the skills we just saw in action. We mastered nested logic to create a sequence of checks. We used a simple comparison, that double equals sign, for security. And we used basic math to update our data. These aren't just abstract ideas, these are real, practical skills that make software work.
All right, you've seen the logic, you've seen how it works. Now it's time for your final test, a little victory challenge. This time, you get to be the computer. Okay, Using the exact logic we just built, what would happen if a user entered 9999 as their PIN? What would the program print to the screen? Think through the steps, follow the flow.
And there's your answer. The very first check, is entered PIN equal to correct PIN? That would fail, right? 9999 is not the same as 1234. So because that first condition is false, the computer completely ignores all the nested logic about the account balance. It just jumps directly to that final else statement and prints the PIN error. Game over.
So there you have it, the simple, elegant, and really powerful logic that makes an ATM work. You've seen how these basic building blocks, variables, booleans, and nested if statements all come together to create a decision-making process. This right here is the foundation, and it really just leaves us with one exciting question. What will you build with it?
If this breakdown helped you master the logic and it all clicked into place, please give this explainer a like and subscribe for more deep dives into the concepts that shape our world.